Okay, here's our example problem for Kirchhoff's rules. Here's what we are given. This circuit. Notice this is much more complicated than what we may have seen in the past. Yeah, nothing. All right. Okay, in particular, we have a second battery in here in the middle of the whole circuit, and that kind of tweaks things a little bit. So, what we need to do, the first thing we need to do is to assign directions for our currents. My suggestion to you is find the biggest battery, okay, and whichever direction it's pushing current, okay, make that positive. And so whichever loop it's in, as it goes through it, make that a positive.
Is the one in the middle 19 volts?
10 volts. 10 volts, 6.0 ohms. So it's 2 ohms, 6 ohms, 4 ohms, 10 volts, 14 volts. So if I am doing this, I choose that direction right there. That's I1. Okay. What currents do we have in this thing, by the way? How many currents do we have in it? Yeah, we have 3 different currents in it. Right, so we have a current across the top. We've got a current down here. Okay, so I call that I2. Okay, and then I'm going to call that I3. Okay. All right. Well, the first equation I'm going to write is the easy and obvious one. Okay, and it's going to be the junction rule equation. Okay, I1 is I1 equals I2 plus I3. So I take this junction right here, or this junction, so I1's coming in, and it's going to equal I3 and I2. Yeah? Okay, so here's our equation, except we have 3 unknowns, right? You may see where this is going already. We're going to need at least 2 more equations, okay, to come up with what the other, what our currents are. So, okay, so I'm going to choose, okay, choices. We have another loop. I'm going to choose, I'm going to use a different color for that too. I'm going to choose this loop here. Okay, and so we do our voltage walk. I'm going to start here, and we're going to add 14 volts. Then we come down here, and what happens here? Okay, we're going to lose 4I1. We're going to lose that much potential. Yeah?
Yes.
Come through here. All right. We're actually going to gain another 10 volts. And then we will lose 6I3, because the current going through here is I3. And we come back around to here, and that whole thing then equals 0. Now, here's where a little bit of inspection comes in. Now we have two equations, 3 unknowns, but we have 2 unknowns in this one, right? So, we need a third equation. As long as it has an I2 in it, we're good. Yeah?
That's right.
So, I don't want to deal with the concept of competing currents here. Okay, so I'm going to take the big one on the outside. That make sense?
Yes.
Okay, so I'm going to take 14 volts again minus 4I1 minus 2I2, and that's also going to equal 0. And voila, we now have 3 equations, 3 unknowns, and you get to solve them. And that's the end of the example.